Good morning, statistics students. It's Friday, March 27th. Hope everybody's doing well. It's Friday, the weekend's almost here, and we're going to slide into it somewhat casually. We're actually going to put to use some of the things that hopefully you learned on Thursday with section 6.3. Okay? If you did not download and watch the PowerPoint presentation of YouTube for 6.3, make sure you do that and either read section 6.3, and the exact pages are in your announcements in this page today and yesterday. So if you haven't read 6.3, do that, and you will need your what they call Table 3, which is Table 3 Appendix B in the back of your text, or the printed one I gave you, which is labeled something else because I pulled that off the PowerPoint website. And if you're still having difficulty reading areas and probabilities under the standard normal curve, you want that nice little handy-dandy red and blue kind of guide template that gives you examples from 6.1 to 6.7 of just about any area underneath the standard normal curve and how to appropriately read it and then calculate the corresponding area slant probability. If you got all that, you're in good shape. This is just a piece of cake. You also will need, if you might need to stop this video, go to the assignments page for today and download section 6.3 problem set 1, or it may say problem set 1A. All right, and there's several different problems on there. 3 different types of problems. I'm going to work an example from each section and then let you work the remaining problems. And between that and the knowledge you've already acquired, the materials you have in front of you, the textbook, the PowerPoint, the table of areas and probabilities, and the kind of template that we created actually 2 weeks ago today on that Friday, our last day together, you should have sufficient knowledge and expertise to solve these. So I'm going to do number 1, you're going to do number 2 on your own after we conclude the video. So it says given a x equals 58, so x is just a particular data value that has a mean of 43 and a standard deviation of 5.2, we're just going to calculate the z-score. And as you recall, the z-score is how many standard deviations are you away from that mean of 43, okay? I always like to draw a picture because I think that solidifies in my mind, or hopefully your mind, what you're being asked to solve. So if we just very crudely and rudely draw a standard normal curve, okay? Doesn't have to be perfect. You do know it's symmetrical. Mine isn't, but it actually is. The mean is actually in the middle, which is 0 standard deviations to the left or to the right. We got half the data to the left of that 0, half the data to the right. In this case, our mean is 43. Okay? Our mean is 43, and we're 0 standard deviations away from that. All right? And so it's asking you, given x is 58, u is 43, standard deviation is 5.2. So it's asking you, we're just going to roughly draw 58, probably would be somewhere right in here. So it's asking you, what's the z-score for that corresponding line? And then we can find the corresponding data on either side of this. The table's going to give you this side, and no matter what you get on this side, you subtract that from 1, you'll get the area of probability that's on the right side. Okay, so you know the z-score calculation, which is also how many standard deviations we are from the mean. And you remember that formula as being x minus the mean over the number of standard deviations. And we've got x, we've got the mean, and we've got the standard deviations. So we can find out what z equals. So we're just going to plug all that in. All right, so it'll equal x is 58, and the x always comes first. Otherwise, you're going to end up with an opposite sign z-score than what the actual answer is. Minus 43 over 5.2. All right? So 58 minus the 43 over the 5.2, and we do all the math in your TI 83 or 84, you're going to come up with a value of 2.88. So in this case, with 0 standard deviations, with a mean of 43, with an X value of 58, that is 2.88 standard deviations above the mean. Okay? It doesn't ask you to calculate area. It doesn't ask you to calculate probability. It just wants you to determine what that z-score is for that 58 data value. That's it. Stop right there. We're not even going to look at the table. We're just practicing calculating the z-score or number of standard deviations a particular value is for the mean. I hope that makes sense. It should be familiar because we've done different aspects of this, so probably over the last, 4 weeks now? So you should be becoming somewhat proficient. So we're 2.88 standard deviations above the mean. You always know that standard deviations on the right side is going to go from 0 to approximately a positive 3.3, 3.4. And to the left of that mean, it's going to go to a negative 3.3, 3.4. And that's going to capture almost 100% of your data because, quote unquote, it's a standard normal curve. Give me 1 second as I slide the screen up and clear my board, and you should be able to do number 2 very well and very easily on your own. All right. Problems 3 and 4 are very, very similar. I'm going to walk you through number 3. You're going to do number 4. Okay? So let's just, excuse me, read what we're being tasked to do. It says IQ scores are normally distributed with a mean of 100 and a standard deviation of 16. All right, so we've used IQ score data before. That in SAT, this text likes very much. So if, again, I draw my kind of very crude standard normal curve, all right, my mean is actually 100, okay? And it says, determine the probability that a randomly selected person will have an IQ score between 100, which we've already got, that's our mean, right, and 120. And we're just going to kind of guesstimate what 120 would be. So it's asking you, if I selected from a pool of people, maybe it could be students here at Benedictine, what is the likelihood or what is the probability that someone's going to fall in between an IQ score of 100 and 120. So we need to find this area. And if you recall, using that kind of guide of how to read standard normal curves, the data on that table fills from left to right. And we've got two X's here, so we've got to calculate 2 z-scores, all right? Well, you already know what the z-score is of 100. I'm going to walk you through it just in case, but you shouldn't have to do any math because our z and our x are identical to each other. So again, using the z-score calculation, it's z equals x minus the mean over the standard deviation. So we're going to calculate it once for 100 and once for 120, all right? So our first one using 100 is z equals 100 minus 100 over 16, all right? And if you do the math, we get z equals 0. And at z equals 0, if we go to our actual table, we know that at z equals 0, 0 standard deviations away from the mean because our z and our x are identical, is 0.5000, all right? Half our data is right there. All right, so we also need the z-score for 120, all right? So we're going to apply the same math. So in this case, it's going to be z equals 120 minus the 100 over 16, all right? Which z equals what? 20 over 16. And that would equal to 1.25, I believe. Correct. All right, which makes sense because we know all the z-scores on this side of the table are going to be positive. So the z-score here at the mean, where it's 100, we just determined is 0. And for the 120, our z-score equals 1.25. All right? So when we go to the table and look up the corresponding area or probability of a z-score of 125, as we remember how that table was constructed, it's going to give us all the data going back to the left, right? It's going to give us this whole area going all the way back to the left side of your curve. And if we look that up in the table, you should find it as 0.8944. And just to refresh your memory, remember down the left side of that table is the whole numbers in tenths, so come down to 1.2, and then look over the top margin and come over to 0.05 as the hundredths, and where the 1.2 and the 0.05 intersect, you'll find the 0.8944. Got one last step to do here. Is, again, we're asked to determine this area, this probability. The area and the probability are one and the same. That's the nice thing about the standard normal curve. So we've got to subtract out at 0.5000 from the 0.8944 for our final answer. So it would be 0.8944 minus 0.5000, which equals 0.3944. So 39/100ths, or 39% probability or likelihood that if you selected someone at random from a pool of, say, Benedictine students, is that they will have an IQ score somewhere between 100 and 120. I hope that makes sense. We've used different aspects of this probably over the last 4 to 6 weeks, so it should be fairly much of a review and not all brand new. All right, let's flip over to the back side. While you're doing that, I'm going to readjust my screen, and I will walk you through. I think we're probably going to do number 8, because that's probably one of the more difficult problems, and if you can do that, you can do the other set that's actually there. All right, the other what, 5 of them? Yeah, other 5 of them. All right. So it says at the top says given that x is a normally distributed random variable, which we can use the standard normal curve, with a mean of 60 and a standard deviation of 10, determine the following probabilities. So it's asking you what's the probability that x is going to be greater than 65 and less than 82. So again, let's just draw a little picture so we have solidified in our mind what we're being asked to solve. So if you draw the curve, 60 is in the middle, that's our mean, and we're a little bit to the right of the mean, so we're going to go from 65 to 82. This is not to scale. So it's asking you for this area right in here. All right? Thinking back of how what we did on the front page, so we're going to calculate 2 z-scores, one for 65, which is going to give us all of this area back this way, and then one for 82, which is going to give us all the area back this way, and we're going to subtract the smaller from the larger, and it's going to give us this area and this hash marked area. So 2 z-scores, and then we're going to find the difference between the two. So let's just set them both up, all right? So remember, it's always, I'm going to put the formula up here. It's z equals x minus the mean over the standard deviation. And we're going to use that for both of these calculations. So in this case, we've got z equals 65 minus 60 over, what did we say our standard deviation was? Let's see here, 10. All right? And I'm going to set them both up because we're going to kind of work them simultaneously. And the other value is 82 minus 60 over 10. Fairly basic math, you might not even need a calculator. So in this case, we got 5 over 10. So our z-score for 65 is 0.50. And for 82, we got 12 over 10, which equals what? 6/5. And if I did the calculation, let's see, what would that be? 6/5. Let me grab my table because I didn't grab one. Just hold on one sec.